Okay, good morning. I wanted to make sure to have some practice so that when we return to school tomorrow, we are fully prepared to pick up where we have left off on solving compound inequalities. So these should not be anything that's super difficult, just some review things of stuff we've already done. I do want to point out an error that I made last week when I was solving something. All of these right here, so I used the wrong conjunction. I do want to say really quickly on these examples where they are separate. Last week, I said that if you had two pieces, that was an and compound inequality, and I misspoke. I made an error. I am not perfect. Those are ors. So if they are not together, it is either smaller than 3 or bigger than 2. It is smaller than or equal to 0 or bigger than 5. It can't be in both places at once, and so those are ors. If it could be in between both of them, I would say it is between -2 and 1. That would be an and statement. So these right here, again, would be or statements. And that is my fault, and it's an error, and I wanted to fix it as I was doing some things, because this is an example of an and right here where it's both, and those are ors. And so I wanted to make sure to fix that really quickly before I forgot about it. Okay, so jumping right into solving these. So it says solve the compound inequality and then graph each solution set. So we are going to be graphing these on a number line. And remember, the golden rule of solving inequalities is whatever you do to one section, you do to another. So it's not just one side. Like if I had a traditional inequality like that, you want to make sure you do the same thing to all three sections. So if I'm isolating my variable f, I can see that's f minus 6, and so to undo that, I'm going to add 6, and I'm going to make sure to add that to all three sections. So 2 plus 6 is 8, is less than or equal to f, is less than 5 plus 6 is 11. So that tells me that 8 is less than or equal to f, is less than 11, or it's between 8 and 11 is another way you could say that. So on my number line, I'm going to go ahead and put my 8, 9, 10, and 11. And so I can see that there is an equal to on the 8. So that means it's a closed dot. There is not an equal to on the 11. And they are connected because the f is between them. It's really just that simple. At any point, if you're watching this, you could pause and try something on your own if you haven't already. Especially if it's like a new problem type, you've watched one, like number 2 is similar to number 1. So it would be, valuable to pause and solve this on your own and then continue. So I have n plus 8. The undo of addition is indeed subtraction. So I'm going to subtract 8 from all three sides or all three sections. -6 minus 8 is -14, is less than or equal to n, is less than or equal to 5 take away 8 is -3. So if I'm going to graph this on a number line, I have -14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, -3. And you wouldn't necessarily have to put all those. I don't know why I did, but here we are. You could just put your 2 points. So there's equal to on both of these. So these are both solid dots. And so that is my solution. It's between -14 and -3. Okay? So when I go to solve this one, I have 2 different statements here. And so I have first y minus 1 is greater than or equal to 7. And so I'm going to add 1 to both sides. And so that's going to give me y is greater than or equal to 8. Okay. got my or statement. And then I have y plus 3 is less than -1. So subtract 3 from both sides. And so I have y is less than -4. And so that is an or statement. So when I go to graph these, I should have 2 of those. So -4 first, it's an open circle. It is going less than. Way up here, I'm going to have a 0, and then I've got my 8, and I know that 9 is going up. And so this is greater than or equal to 8. So that's a solid dot, and it's going up just like that. So those are 2 different sections. It can't be in both of them at the same time, so it is an or statement. Okay? Again, at this point, you could pause if you wanted to try this on your own. T plus 14 is greater than or equal to 15. So I'm going to subtract 14 from both sides. So T is greater than or equal to 1. Or T minus 9 is less than -10. So if I add 9 to both sides, I get T is less than -1. So notice here, like in this one, obviously it's between them. They do not have to be the exact same statement in order to be a compound inequality. They can be different statements just attached by that conjunction, or it also could be different statements attached with an and that would mean you're looking for that intersection of where it's both. So I have my -1. So greater than or equal to 1, so solid dot going up, less than or -1, so going down but not a solid dot. So again, not connected would be an or statement. That's a correction from what I had in the notes last week, and that's because I had an error. Okay? Again, it doesn't have to be necessarily, we've done 1 steps, so here's a 2-step. Looking at this middle statement, if I'm looking at this, I have 3p plus 7 in the middle. So first thing I would have to do is get rid of the addition to 7. Please excuse my dog if she's barking. So -5 take away 7 is -12 is less than 3p is less than 15, because 22 take away 7 is 15. And so now I have 3 times p, and so the undo of multiplication is division. And notice I am not dividing by a negative. I am dividing by a positive, so I don't have to flip anything. So -12 divided by 3 is -4, is less than p, is less than 15 divided by 3 is 5. And so when I graph this on my number line, I know that the solution to my inequality is between, that should be an equal to, and so should that, is between -4 and +5. It's also equal to the 5. I would always say, if you noticed what just happened, I had forgotten my equal to here and here, and I had to fix it really quickly. Always double check those inequality symbols. Like as you're going through, make sure like, okay, those are the same. I didn't have to flip anything. These are the same. I didn't have to flip anything. Like little things that you didn't forget the equal to, you didn't accidentally flip something, or you didn't accidentally add an equal to where there shouldn't be. Okay, again, this would be a good one to pause. So first thing I'm going to do is subtract 4 from all 3 sections. And so that gives me -3 take away 4 is -7. It's less than or equal to 7c is less than 18 minus 4 is 14. divide everything by positive 7. Again, I'm dividing by a positive, so there's no need to flip anything. So negative 1 is less than or equal to C is less than 2. And again, double checking my inequalities. These are all less than or equal to's. I didn't flip anything on the right. Those are all less thans. I didn't flip anything. So that tells me that my solution is between negative 1 and positive 2. It could be equal to negative 1, therefore it has a solid dot. It cannot be equal to 2 and has an open dot, okay? Hopefully that makes sense to everybody. Okay, looking at number 7. So again, these statements do not have to be the same. We just solve them independently and then deal with the or once we're done. So looking at the first one, I'm going to solve this, and I see first thing I'm going to do is I'm going to flip this. So 4m minus 2 is less than or equal to 22. So I've just reversed the whole thing. And remember, the way that we can tell that is my pointed side is touching the 4, and the pointed side is still touching that 4m minus 2 statement. So I'm going to add 2 to both sides. And so that tells me I'm going to bring down the 4m is less than or equal to 22, and 2 is 24. If I divide both sides by 4 to isolate the m, I get m is less than or equal to 6, okay? Or, bringing down that or statement, okay? So I've got a positive 5 and a negative 3m. So if you don't like the way this is written like that, you could always rewrite that as negative 3m plus 5, because the 5 itself is positive, is less than or equal to 13, if that helps you see more clearly what it is that you need to do. So we're going to subtract 5 from both sides, and so I get negative 3m is less than or equal to 8. And when I divide both sides by negative 3, now notice I'm dividing by a negative, which means I have m is greater than or equal to 8 divided by negative 3 would be negative 8/3. And so notice how we flipped that sign because we divided by a negative, okay? Oops, I just realized I made a mistake. So notice really quickly, and I'm going to point this out, that's a negative 13, and I did not copy down the negative. So when I did that, that's actually going to completely change my answer. So negative 13 minus 5 is negative 18. Negative divided by negative is a positive, and 18 divided by 3 is 6. Whew. Okay, so there we are. Now, this is an odd answer, and by odd, I don't mean numeric, like the number itself is odd. I'm saying it's an odd answer. So notice how I've got m is less than or equal to 6, which is, I'm going to do this side in blue. So less than or equal to 6 or down. Let's do this side in purple. This is 6 going up. Notice that means it's always going to be true because literally every part of my number line is covered. So in this case, my actual answer is all of it. Like, it's all going to be my answer. But this is kind of how you can see sometimes, like, it's either going to be less than 6 or greater than 6, but in this case, that's all of it. So here we are. All right, looking at number 8. Notice on the first one, there are 2 m terms. Not a big deal. We just have to combine those. And so if I subtract 17m, and I'm subtracting the 17m and not the 10 because I do want my variable on the left-hand side. I want it to be first. So 10m minus 17m is negative 7m minus 7 is less than 0. If I add 7 to both sides, so I get negative 7m is less than 7. And in this case, I am dividing by the negative, which means when I bring this down, I have to flip my sign and I get negative 1. Or negative 6m is greater than 36. So it's literally a one-stepper. I'm dividing by a negative, which means I'm going to flip my sign and I get a negative 6. So if I bring these down together, so m is bigger than negative 1 or it's smaller than negative 6. So if I put my negative 1 here, it is not an equal to, so it's an open circle. Negative 6, again, not equal to, it's going down, open circle. Just like that. So it's either bigger or smaller. Okay. If you have questions, make sure you've got this. I'm on my Zoom link all day if you've got questions for me. Okay, so I wanted to look at a couple of word problems to make sure that we are comfortable reading and writing them and then solving further. So if we're looking at this first one, it says, in Randy's town, all stand-along signs must be exactly 8 feet high. When mounted atop a pole, the combined height of the sign and the pole must be less than 20 feet or greater than 35 feet. So, yes, so that they do not interfere with the power pole lines, okay, or the power and the phone lines. So you can kind of see it's got to be either below the power line or above the power line, okay, which tells me this is going to be two separate statements because I couldn't connect these two heights. It's either, like I said, above the power lines and above, or power lines and below, okay? So that picture is definitely helpful. And so part A says, write a compound inequality to represent the possible above ground height of the pole X. So again, this is telling me that X is the height of the pole. And in the problem, it says, when mounted atop the pole, the combined height of the sign and the pole must be whatever. And they already tell you that the sign is 8 feet tall. So that means my sign and the pole, which I'm going to go ahead and write this right here. So sign and the pole is going to be, the sign we already know is 8 feet plus however tall my pole is X, okay? So when mounted atop the pole, the sign must be, or the combined height must be less than 20. So 8 plus X is less than 20, or 8 plus X is greater than 35. So that's my compound inequality. I'm going to copy this and solve it now. This becomes very easy to solve. So when I solve the first one, if I subtract 8 from both sides, I get that the height of my pole must be less than 12, or subtracting 8 from both sides, that the height of my pole must be bigger than 27. And again, we are talking about feet. So if we're explaining what we have, we could say, the height of the pole must be less than 12 feet or greater than 27 feet. And if we graph that on a number line, it's not equal to, it says, or it didn't say that. So less than 12, open circle, going down, greater than 27, open circle, going up. Just like that. So it's in how you read these, so make sure you are reading it. It is definitely okay to do these intermediary steps to help you so that anytime I see like sine and the pole, then I already know that's 8 plus x. I'm not having to think through that multiple times, okay? Looking at number 10, the human heart circulates from 770,000 to 1,600,000 gallons of blood through a person's body every year. Write a compound inequality that represents the number of gallons that the heart circulates in one day, x. Okay, so if I'm talking about the amount that's in one day, okay, I know that this is 770,000 is the annual, right? So that would mean if I could do, well, this is supposed to be for a year, which means I have to make this become a year. We're going to assume a normal year. They didn't say it was a leap year, so we're not going to assume that. So to do for the year or annual, that's what annual means, would be, or let me say 1 year would be 365 x. Okay? So if we're talking about what we're looking at, we've got 770,000 is less than 365x is less than 1,600,000. I'm going to move this so I have a little more room. So there's my inequality. When I go to solve it, I'm just going to divide everything by 365. And you could have thought to do that ahead of time, but to actually have something to solve, that's why I didn't do it that way. So when I divide 770,000 divided by 365, I get, now this is an opportunity where normally I would say it doesn't go in evenly, so you would leave it as a fraction. But it says in the problem to solve and round to the nearest whole gallon, okay? So before I round anything, I'm going to write exactly what I get. So 2,109.589, okay? Normally, I am not going to have a decimal like that, but because it tells me to round, I need that. This is the exception to the rule. And then 1.6 million, or 1,600,000, I get 4,383.562. Okay? And so it tells us to round to the nearest whole gallon, which means I'm looking at this number here, the number, if I round to the nearest whole number, I look at the next place value. And so if that is 5 or higher, that means this gets rounded up. So 2,109 becomes 2,110 is less than x is less than, that's a 5, so that's going to go up, 4,384 gallons per day. So we can say the heart circulates between 2,110 and 4,384 gallons of blood per day. And I knew that this was a connected inequality because it does say between. Okay, whereas up here, I knew that they were not connected because it says it's this or that. And again, my picture was helpful. Here, that word between, or it circulates from this to that, tells me here we are. Okay, and then on my number line, and this is where, like, it's not realistic to draw the 2,000 some odd spaces between these two. But 2,110, 4,384. I don't have any equal tos. Okay, last thing that I want us to look at is making sure that we know how to write these. This should be pretty easy. We did this last week. So these are connected, which tells me my answers are going to be connected. So -3 to 3. We put less thans. That's going to be an equal to because of the closed dot, and you could put whatever variable you want. You could put x, you could put a, m, whatever. I'm just going to put a, okay? So a is between -3 and 3. At any point, you could pause these. I have a 1, I have a 4. When they're connected like this, we put less thans. They both are solid dots, so it's got an equal to, and you put your variable between. So 1 is less than or equal to b is less than or equal to 4. Now, these are not connected, so I automatically know that I'm going to have an or statement here because it can't be in both places at once. And so I have C is smaller than -2 because it's going down, or C is greater than or equal to 1. Again, feel free to pause. These are not connected, so I know I'm going to have an or statement. D is less than -1. Or D is greater than 2. Number 15, again, they're not connected. So, or statement, E is less than or equal to 0. Or E is greater than 3. 16, these are connected, so that tells me my variable is going to be in the middle. We put less than or equal to's because they both have solid dots, -2 and a 3. Not connected, so I'm going to put an or statement. G is less than -1. G is greater than or equal to +1. And last but not least, again, these are not connected, so I have an or statement. H less than or equal to -1. Or, sorry, I'm going to make a little more room there. H greater than 2. Hopefully you have found this helpful, and we can pick up tomorrow and jump right into just some extra practice and making sure that we are good on compound inequalities. Let me know if you have any questions. I am available to answer anything that I can help with.